Hello and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and on this video, we'll be covering trends that are found in ionic radiuses. Let's get started. So in the previous video, we talked about trends that exist between atomic radiuses. And again, that's just based off of that distance that's found between the atom, the center of different atoms of the same element. Well, when we think about how ions are going to be impacted, the size of the ions, we need to remember that really there are two different types of ions that are created. There are your anions, which means we've gained electrons, and there's cations, which means we're losing electrons. And so the trends that we're going to be looking at, we have to think about, well, which atom in particular are we dealing with? Much like before with our our neutral species, as you go down the periodic chart, the size of the relative radiuses will increase. But now when we think about our cations and anions, we don't want to do a continuous trend across the board, across the rows, because again, there's two different things happening. Your cations are traditionally going to be smaller than your neutral atoms because they're losing those electrons and they're able to come in a lot closer. And your anions are going to be much bigger than your neutral atoms because you now have excess electrons. And so when we're dealing with assigning the trend is going to be that they're going to increase for the cations as well as increase for the anions across the back to the left. However, notice it's not one trend, and that's intentional so that you don't think that a cation is bigger than an anion. Now, typically, the larger the positive charge that you're dealing with, the smaller it will be. And so if you're looking at something in the same row that has a +1 charge versus a +3, that +3 will be much smaller. So when we're dealing with things that are called isoelectronic, which means they have the same electron configuration or the same number of electrons, keep that in mind. The smaller cation will be tied in with the thing that has a larger positive charge. And when we're dealing with things that have the same number of electrons or same electron configuration, the larger the negative charge, the bigger that ion will be. Okay. And again, there are exact values that you can assign, but we really just are focused more on that overall trend. So you can see in this picture here that shows you the size difference between a neutral element and its cation. And so again, much like we saw before, we do see that increase down the periodic table. And if you look at the size, things with the larger charge are smaller. And so you got that increase going to the left as well. Okay. For our anions, remember the anions, as I add in additional electrons, the size is going to get bigger. And so again, as you go down the periodic table, the overall size is increasing. And as you get to higher negative charges, the size will get bigger as well. All right. And so now when we're trying to choose between who is larger versus who is smaller, we take the relative location and the charge into consideration. So if we're dealing with something like sulfur or its anion, well, we know the anion is going to have more electrons than the neutral species. And so we would expect that the anion will be the larger of the two. For calcium versus its cation, well, calcium cation has lost 2 electrons, and so we would anticipate that it should be smaller than the neutral atom. So we would pick calcium as the larger. Now for bromine and krypton, well, now we're not dealing with the exact same element, but we are dealing with what are considered to be isoelectronic species. They have the same number of electrons because bromine anion has gained that extra electron. And so now we're looking for the thing with isoelectronic species, we're looking for, well, who has the more negative charge? That will tell you who is going to be the larger of the two. And so in this case, bromine ion or anion, the Br minus will be the larger of the two. Okay, so let's try putting some things in order. So here we have Zr +4, Ti +4, and HF +4. And so you can see all of those are found in the same group. And so we know we're going to have that increase occurring down the group. And so the smallest of this would be our Ti4, followed by Zr 4+, and then HF 4+. for sodium, sodium ion, magnesium ion, fluorine ion, and neon, well, again, you want to just really quick to check to see, are these isoelectronic? And indeed they are. With sodium, we have 11 protons and only 10 electrons for the sodium ion. For magnesium, we would have 12 protons, 10 electrons. For fluorine, we would have 9 protons, 10 electrons. And for neon, we would have 10 and 10. And so when we're trying to figure out, well, who would be the bigger one or who would be the smaller one, you're going to be looking for these charge differences. So we know the cation that has the larger charge will be the smallest. So our smallest one here would be magnesium 2+, followed by sodium plus, followed by now our neutral species, and then our anion. Okay, so again, isoelectronic, you're looking for, well, if there's a large positive charge, that's going to be the smaller one. And if there's negative charges, that will be the larger. All right, and then the last set, we have iodine, bromide ion, gallium ion, and indium ion, excuse me. And in this case, we do not have isoelectronic species that are present here. And so we're going to really be looking at the overall location on the periodic table. Well, first things first, we know that our cations are going to be smaller. So if you compare the space for gallium versus indium, we would say the thing that's furthest down is larger. So we would start by saying gallium first, followed by indium with the charge. And then for our ions, our anions, we know that the lower down will be bigger. So we would say next would be bromine with a negative charge, followed by iodine with the negative charge. I hope this video helped you understand the different trends that exist with ionic radiuses. Make sure you guys like, comment, and subscribe, and come back for more videos. See you guys later. Have a great day.